In this video, we're going to use parametric equations to simulate Earth falling into a black hole. So one revolution is 2 pi. So this here would be 2 pi, and then this here would be 4 pi. And we're going to make the journey time, let's say 7 seconds. So let me just illustrate it. So Earth is here at the moment. So press play. So we're going to simulate it, and Earth will fall into this black hole. Okay, so that's our aim. So let me just jump back to here. So first we need to create the parametric equations for the spiral. So start out with our unit circle of radius 1. So when you have a circle of radius 1, let's say this angle here is t. The height here is given by sine t. The across here will be given by cos t. So the x location is given by this. The y location is given by this. So if you punch this into your graphical calculator, it should draw a circle in parametric form. Because remember, the idea behind parametric form is that you've got this thing here, which we would imagine it as time. Time starts at 0. Let's say 1, 2, 3, and so on. All the way around here is 2 pi. But let's just imagine all the way around here is 360 degrees. Let's work in degrees. Just imagine it in degrees, so it's easier to explain. So imagine this whole thing here is 360 degrees, even though we're working in radians. But let's just imagine it's degrees. All the way around here is 360 degrees. If we cut this up into 360 equal pieces, so one increment of time would mean there's an increment of an angle. Another increment of time would mean another increment of the angle. So we're really using the angle to simulate time. So another increment of time. So in 3 seconds we would have done 1, 2, 3. So the planet would be here, Earth would be here. Another second later, Earth would be here. Another second later, Earth would be here, and so on. So let's punch this into our graphical calculator. It should give us a circle. So let's start a new one. So if we punch in cos t, sine t, and then from t being from 0 to 2 pi. Okay, so that will give us a circle, which is good. So hang on. So now we need to create a spiral. You see, if you stick a t in here and a t in here, then an increment of time. Normally, if it's always 1 and 1, you're going to get a circle. But then as time increases, if you stick a t in here and a t in here, the radius will increase as time increases. So you've got your time here, 0, 1, 2, and 3, and so on. And as time increases, you can see the radius gets bigger and bigger. So let's go back to here. If we stick a t in here and a t in here, you can see that the radius gets bigger and bigger as time goes on. Wait there. T sine there. So that would be 1 revolution, 2 pi. But the thing is, we want to do it by, well, we want 2 revolutions, so that would be 4 pi. So let me just minimize this. So we've got our spiral from 0 to 4 pi. So now let's go back to here, from 0 to 4 pi. So now we want to create our part. We want to create our planet. So let's go back to here. If we stick bracket a cos a, where a will be our slider, a will slide back and forth later on. So a sine a, close it off, add our slider from 0 to 4 pi. So that's our planet Earth there. and if we press play, but the thing is, we want the planet Earth to, hang on, we want planet Earth to fall into the black hole. At the moment, it's going away from the black hole. So hang on. So we want, so currently, hang on. Currently the planet is doing this. Starts from here, because when t equals 0, it starts at the origin, and then it's doing this at the moment. We want it to do this, to start here, then go all the way back in here. Well, this here is 2 pi. This here is 4 pi. 4 pi. So if we do 4 pi, take away wait there, before we do that, we want the journey time to be 7 seconds. So all the way around here is 4 pi. 4 pi. If we cut up into 7 equal pieces, so cut up into 7 equal pieces, and then stick a t in here. So this here will simulate. This here will give us a journey time of 7 seconds. So let's go back to here. And if we stick, all the way around here is 4 pi. So it will be 4 pi, and then we've got to divide it by 7, cut up into 7 equal pieces. Hang on, divided by, bear with me, divided by 7. Close this off, and then do the same over here. Do the same over here. 4 pi divided by 7. Divided by 7. Close it off. And then, we want the radius to coincide with the angle. So this will be 4 pi divided by 4 pi a divided by 7. Close this off. Hang on. Close this off, and then do the same over here. So bear with me. Let me enlarge this. Do the same over here. 4 pi, and then divided by 7. So now, press play. Oops, something's not right. Bear with me. 4 pi. Hang on. Let me think. 4 pi divided by 7. It should work. Oh, from 0 to 7 seconds. So now we're changing this from 0 to 7 seconds. And then you can see the journey time is 7 seconds. Hang on. So when time equals 0, Earth is at the origin at the moment. By the time, 7 seconds later, you can see it reaches here. But the thing is, we want it to start right at the end here and head towards the origin. So when t or a equals 0, it should start here. Bear with me. So at the moment, when we want it in such a way that when t equals 0, the Earth should be here. At the moment, when t equals 0, it starts at the origin, but we want it to be here. So the way we're going to get around this is to do this. Well, this here is 2 pi, 4 pi. So what we're going to do is 4 pi, take away, what was it earlier? 4 pi a over 7. So this here would, so when t equals 0, it starts at 4 pi. And then, by doing this, you will revert everything, and the Earth will head towards the origin. So let's insert this. So hang on, back to here. If we stick a 4 pi, 4 pi, take away this, and then 4 pi, take away this, and then 4 pi, take away this, and then 4 pi, take away that. Let's put these in brackets. Hang on. Bracket, close bracket, and then yeah, that should work. So let's put A back to 0. See, when time equals 0, Earth is right here, and then as time goes on, by 7 seconds later, it will reach the origin. It would reach the origin. So if we press play, you can see it's falling towards the origin. But to tidy this up, you can see that this here is repeated all the time. So let's just call it B here. Let's just invent a new variable. B equals 4 pi, take away 4 pi A divided by 7. Let's just call that B. And now we can get rid of this and call it B. B. And then get rid of everything here and call it B. And then get rid of everything here and call it B. Get rid of everything here. So whenever you have repeated code, just create a new variable there, B. So if you want to change anything, you change it in one place rather than having to change it in so many places. So now press this, and it's falling towards the origin. Okay.